The XMind logic shift. XPENG's release of the XMind framework this June marks the first time a production world model has successfully integrated visual chain of thought to solve real-time, temporal reasoning. Unlike traditional perception-to-action systems that map pixels directly to steering commands, this architecture forces the model to generate a proactive reasoning trace before any execution occurs. The technical report indicates that by embedding an efficient Video-CoT, the system can hypothesize the spatial-temporal evolution of moving objects, effectively doubling the forecasting horizon in complex urban environments. It is not just about identifying a pedestrian, it is about simulating their likely trajectory through a latent causal graph before the vehicle moves. Interleaved latent reasoning traces, the underlying mechanism, detailed in the June 5 VTI-CoT paper, introduces visual textual interleaved reasoning. Rather than producing a long string of natural language text, which introduces a massive verbosity tax, the model uses latent thought patches to represent spatial relationships. This dual-stream approach handles the visual manifold in one set of layers, while a secondary transformer block calculates causal weights. By rendering these internal reasoning traces, the model maintains grounding in the actual video frames, preventing the common failure mode, where language priors cause the AI to hallucinate physics that aren't present in the visual data. This is a structural change from simple frame prediction to explicit logic-based synthesis. The 62% ceiling. Despite the marketing around OpenAI's GPT-5.6 Sol and Google's Gemini 3 Pro with DeepThink, the data from the June 26 VCR bench update tells a more sobering story. Even these frontier models are hitting a ceiling of 62.8% on the video chain of thought score. The failure isn't in the logic itself, but in a persistent perception bottleneck. If the initial visual summary misidentifies a depth cue or a fast-moving object, the entire logical chain collapses into a structured hallucination. We are seeing a massive 5x increase in inference latency for these reasoning steps, yet the accuracy gains on long-horizon tasks are only marginal when compared to smaller, fine-tuned video-only models like Video R1. The move toward causal simulation, the shift from visual synthesis to causal simulation, is the defining transition of mid-2026, moving the industry away from simple frame generation and toward verifiable world modeling. By integrating video chain of thought, as seen in both the XMind deployment and the recent VTI-CoT benchmarks, developers are prioritizing logical consistency over pixel-perfect aesthetics. For builders and engineers, this means the focus is moving toward optimizing the logic nodes rather than just scaling the parameter count of the diffusion decoder. The real value is no longer in the final video output, but in the internal causal graph that the model builds to explain the world. Watch for the release of the Chronos Logic 1 benchmark in late July, which will likely be the first test to quantify whether these reasoning traces actually lead to safer real-world autonomous behavior, or if they are just expensive, high-latency explanations for existing heuristics. Subscribe for more.